Good morning, my lovely 12s. Right, buddies, here we go for our second lesson in our brand new unit of dynamics. So I hope you found the first topic all right. I am conscious that I want to give you guys a little bit more time to practice. So I can't promise you because I don't know exactly how long this video will take, but I'm hoping that today's lesson's a little bit shorter to give you some more time to practice. And then also we will be aiming to get a practice lesson in soon enough as well, just to really make sure that you guys get how to do these dynamics questions. So, before we start, do you guys remember the steps to solving every single dynamics question? Well, if you said step 1 is to draw a picture called a free body diagram, that's absolutely right. Step 2, to do a net force equation in either of the two directions. And step 3, to use inline substitution. Well, you've got it, my buddy. So I hope that you have your head around how these guys work, and I hope that this will be not too bad for you. Okay, so it's called Dynamics with Vectors today. And it's just a bit funny, to be honest. In all of the time I've ever done physics, I've only ever seen vectors and dynamics questions a few times. They're usually only used for questions that are in 3D or for questions with non-constant acceleration and stuff like that. They're usually used for kind of high-end questions, vectors are. So when we use them for these types of questions that we're going to do, it's pretty kind of extra. So what I would suggest to you is just to break the questions down so that they're not questions about vectors anymore. And that's the method that I usually use when we go through. Cool. So let's do it. First question. It says, in this question, I represents the unit vector due east. J represents the unit vector due north. It says a particle begins at rest from the origin. It is acted upon by 3 forces. This one here, a force of 2i plus j newtons, a force of 3i take 2j newtons, and a force of minus i plus 4j newtons. Cool. And it says find the resultant force in the form pi plus qj. And that's it. So we're after the resultant force. Okay. Now, just as a really brief recap, that's what I put this picture here for us, just to talk to you guys about. I hope that you remember what I and j are from when we did the vectors unit together a few, probably months ago, actually. And yeah, just remember what they are. Usually, 9 times out of 10 in maths, we just have the x direction and the y direction, which you're all really super familiar with. Now, I and j are just single steps in each of the two directions. So if I told you to go in the direction of 3i, that would mean take 3 steps along the x-axis. Same deal with j, but j is for the y-axis. If I said go 4j, it would be go 4 steps up the y-axis. If I said go 3i plus 4j, it would be 3 across first and 4 up. So I hope you remember the ideas of vectors. In this question, it just happens to say that I and j represent north and east, but just so you guys remember that that's also how the coordinates or the compass works as well, so never eat shredded wheat. So it's kind of just in keeping with that. So it's no big worries really. Cool. Now, what do we do first, my buddies, in every single one of these questions? We're after the resultant force. What do I have to do first? That's it. You draw it, my buddy. So start off with your picture. Cool. Now, do we know how big our thing is that we're on about? Nope, doesn't say the mass, so I'm just going to whack an M in it for mass. Cool. Let's get our forces on the picture too. Now it says one of the forces is 2i plus j. So here's what I'm going to do. I'm just going to pop it here, just because it'll be easy to draw, but you can draw them wherever you like, really, the forces. When it's non-specific, like this question, it's just a vectors question, put them where they're convenient. So I'm going to put mine here. Now it's 2i plus j. Here's how this works, buddies. It means that we're coming along 2 in that direction and 1 in that direction. Cool beans, buddies? Do you remember that? So this is the first force, like that. That's the resultant force of it. I'm going to call it F1 for the first force, okay? So that can just be called F1. Cool. Now, second force. Draw it on as well, my buddies. See if you can do it. And you're back. So here we go. Let's have a check. 3i take 2j. It's going to be the same kind of deal again. It's 3 over, there's your 3i, and it's 2j, so that's minus as well, so minus 2j, downward like that. So here's your resultant force just like there. That's the second one, F2. And the third one is minus I plus 4j, which is really convenient because I was like, oh, I'm out of space on the right. But actually, minus I worked really good for me. So F3, we can put it this way. It's 1 this way, minus I. So it's 1 that way, minus I. And then it is 4 up. So up 4, there it is, 4j. And so your resultant force is there, F3. Now, it wants us to say what the overall resultant force is. So, how are we going to do it, buddies? Well, just like we did before, now that we've drawn the picture like this, we don't have to worry about the vectors anymore. The i's and j's have actually helped us in this instance to know how the components break down, so we've not needed an angle. So, whereas sometimes you need to have like a sine or a cos or whatever in this case, you can just put the numbers down straight away. So let's do it. The resultant force is going to have a horizontal and a vertical direction. So let's do it. Starting off, here we go. Hor for the horizontal direction. Pick whichever way you want to be positive. I'm going to go with right as positive because I'm going to guess it moves right. What do you do next? Well, your F net equation, the overall balance of forces. What's moving to the right? Well, you have a 2i. I'm going to ditch the i's though. I'm just going to put a 2. And you've got a 3 as well. 2 plus 3. Cool beans? The i's are only to denote direction. So since I'm in horizontal, I'm just writing 2 plus 3 rather than 2i plus 3i. Cool. Now there's one going backwards as well. It's minus I, so minus 1 for that. It's not asking for the acceleration. It just wants the overall force. So let's do it. F net then, my buddies. 2 plus 3 is 5. Take 1 is 4. It's just going to be 4 newtons to the right. Cool beans, buddies, because it was, well, I don't need that actually. It's positive. We said it was in the right-hand direction, and so therefore that's what you've got. Next thing, my buddies, vert. Pick whatever way you want to be positive. I'm going to go with up. Just kind of a guess that that's the right answer. And let's do it. F net. And what's going up? Well, you have a 4 for this, you've got a plus 1 for this in the j direction, and then you've got a minus 2. So the overall force vertically then is 543 newtons. Cool? Now, unfortunately, it's not okay to just leave them in horizontal and vertical components. We did get our answer. They had asked us to do it in a vector form, okay? This part here, they wanted it in vector form. So what are you going to do? Well, you're just going to combine these two overall forces, the horizontal overall force and the vertical overall force, into just one total overall F net, one total overall resultant force. And here's what it is. It was going in 4 in the I direction, so it's just this. It's 4i. It was going 3 in the vertical direction, plus 3j. Oops, I actually drew an I again. Plus 3j. Whack those two in a bracket. Newtons. Bang. Final answer. And that's what you have there, and that's it. That's it. That's F net done with vectors. So it was 4 horizontally, it was newtons horizontally, 3 newtons vertically. So 4i plus 3j newtons. Bish bash bosh, crushed it. No problem. Cool. Now for part B, you can just use your vector skills from the course. So let's do it. Find the magnitude and the bearing of the resultant force. Well, you guys know what that means already. A magnitude is the size of it, okay? So this is 4i plus 3j. We actually want to know how big it is overall, the overall force, and also the bearing. Here's what I'll suggest. Here's what you've got, my buddies. You've got i's and j's. You've got horizontal and vertical defined already. Let's put them back together just into a force picture. So you ready? We've got 4i, which goes along like this. So there's your 4i. Followed by 3j, so it's going to be upward like that. 3j. Which means the overall force, the F net that we actually drew, is here. F net. And that's that, my buddies. Cool? So if you want to get the magnitude of it, the size of the F net, I'm even going to use the notation from vectors. The magnitude of F net is just going to be this. Well, it's Pythagoras' theorem. It's a right-angled triangle. It's a 3, 4, 5 triangle, so it's just 5. But just to prove it to you, you ready? It's 4 squared plus 3 squared. 16 plus 9 is 25. Square rooted is just 5. It's got magnitude 5, okay? So magnitude 5 is our F net equation. Now it also wants the bearing as the second part. So in order to get the bearing, I forgot the newtons, in order to get the bearing, you just have to figure out how many degrees it is from north. So how do you do that again? Well, draw a little compass rose or star or whatever it's called here. So you're ready? There they go. Never eat shredded wheat. The bearing, my buddies, from GCSE, you guys know, is going to be this. It's from there to there. So how are we going to get that? Well, by getting this first, that theta first. How are you going to do that? Well, trig. I'm going to go with 10 because I won't have to rely on the 5 newtons being right then. So you ready? 10 theta is equal to 3 over 4, just from SOHCAHTOA, which means theta is, where's my calculator? Shift 10, 3/4 is 36.9. 36.9 degrees. So this is 36.9. Now, that's not the bearing because this part's the bearing that goes down this way. That there is the bearing. So you're just going to go 90, take answer, and you're going to get that it's 53.1 degrees, okay? So final answer on this, you just have to combine these two things together in order to say your final answer. And your final answer is just going to be this. Find the magnitude and the bearing of the resultant force. Well, here you go. The overall resultant force then is equal to 5 newtons in a direction of this bearing. And the way you write it is usually with, I don't know if you have to do this or not, but 53.1 degrees is fine. Usually they put a 0 in front to make it 3 digits because it goes up to 360, as you know, to go all the way around. So 053.1 degrees. I don't know if you need the 0 or not there. I can't quite, I know that they often include the 0, so I'm going to do it just to be safe. And that's it. Bish bash bosh, your first ever vector question done. Not too bad. It's the exact same skill as last time, but with just a bit more, little bit more faff to it. That's all. Cool. Rightio. Excuse me. In this question, I represents the vector due east, J represents the vector north. A resultant vector of that acts on a particle of mass that. Find the acceleration and find the magnitude and the bearing of the acceleration of the particle. Okay. Let's do it, my buddies. This is a bit of a fiddly one because it's giving us the resultant force rather than an individual force. So the resultant force is that. Did it say how big the particle? Yeah, it did say that the particle is 0.5, and we're after the acceleration, buddies. Cool. Step 1, my folks. Well, if you feel comfortable, I'm going to say just pause and go. Get ahead of me. If you're not comfortable yet, here we go. Step 1, what is it? Well, yeah, same step as always. You got to draw it. So here we go, nice picture drawn. We do know its mass this time, 0.5 kilograms. Okay, now it's not on a table or anything like that, it's just a 2D kind of square that we're dealing with here. And it says about the overall resultant force, which means it's actually given us F net as it's on about the resultant force. So you ready? Here's the resultant force as a picture, okay? It goes 3 over, 3I over, and 8J up. 8J. Cool? That is the overall resultant force, okay? So there you go. F net is what it's actually given us. Cool? So now what we're going to do, my folks, is we're just going to do the same old thing as last time. If we want to get the acceleration, we're going to have to consider each component separately, okay? We're not going to combine them together as one single vector. I mean, you can, and the textbook does, but I think that it causes confusion. So here's what I'm going to do to make this consistent with all the other ways that we do these. Same old thing as every time. Just define a direction you're working in. Pick a direction to be positive. Right, because all the motion is to the right. So let's do it, buddies. F net then, horizontally, is just going to be equal to the 3. Got it? Because it's just 3 horizontally. Now, F net, as you guys know, is MA, right? So it's MA equals 3. But A was not 0.5. Or sorry, M was not 0.5. Not 0.5. A equals 3. Which means A is 6 meters per second squared. And it's to the right. Boosh! We just got the horizontal acceleration. What do you do next? That's it. Same old deal on vertical. Now the acceleration is going to be up, and everything's going to be up because the force is, it's an overall force you're given. and it's just upward. So there you go. So F net is just equal to 8. Do we know its mass? Well, yeah. It's 0.5 times A equals 8. So A is 16 meters per second squared upward. Cool. So final answer then, my buddies, getting the acceleration then as a vector, it's just going to be the two bits of that together. Acceleration as a vector then, my buddies, is just going to be this. Well, horizontally it was 6. So it's 6i to indicate horizontal plus 16j to indicate vertical, meters per second squared, bish bash bosh as a vector. Now, it's fiddlier doing it that way, it's weirder doing it that way, but sometimes you have to do it that way. It's not useful even in year 12 or year 13 to use these vectors, but trust me when I say that when you get stuff in 3 dimensions, it's very difficult to draw stuff 3D, and so you'll love the vectors then, and yeah, they'll be really useful. You do use vectors loads in physics, just not for the questions that we're using it for at the moment. Cool. Part B is the same as the last time. Find the magnitude and the bearing of the acceleration of the particle. So the only difference this time is we're not dealing with the force, we're dealing with the acceleration. But it makes no odds because it's still just a vector. So here you go. We're going to find the magnitude and the bearing. Well, let's start it off. Draw it out. The acceleration was 6 to the right. 6i. And then it was followed by 16 up. 16j. Cool, which means the overall acceleration is this, a. Cool beans? Now, you guys know that we're after a bearing, so since we're after a bearing, let's get our compass star thing on here. So here you go, there's our lovely compass. North is upward, that means. And the bearing, the answer, my buddies, is going to be this. Okay, of the bearing, it's this angle. Down from north, it's how far around north. Cool. Well, let's start off with the acceleration, the magnitude of the acceleration. So the magnitude of the acceleration, my buddies, is just Pythagoras' theorem. 16 squared plus 6 squared, which means the acceleration is going to be, let's check it, 16 squared plus 6 squared. Well, it's going to be 17.1. 17.1 meters per second squared is the overall speed. If you're watching it zip along the floor, that's the overall acceleration that it's accelerating with along the floor, 17.1. Cool. We need to now get the bearing. So to get the bearing, let's start with that. So let's go tan theta equals 16 over 6, which means then, buddies, that theta is equal to shift tan of 16 over 6, 69.4. 0.4 degrees, which means our bearing is just 90. Take that. Cool. So our bearing is 20. So if that's 69.4, this is 20.6. Cool. So you're ready to go for it. Final answer then, my buddies. Magnitude and bearing of the acceleration. Whack it together as one. The acceleration then, therefore, is 17.1 meters per second squared in a direction of bearing, and I'm going to put the 0 in, just I'm not sure if you need it or not, 069.4 degrees. Boom. And that's your final answer to this question. What's in this purple box says exactly the same thing as what's in this blue box. If you want to be really sophisticated, you can put a half arrow on top of the A to really indicate that it's a vector. And there you go. There's the exact same answer in bearing form, or in like standard old form that you'd normally do it, as well as in vector form. So flying, buddies. Cool. Right then. Very last question, and I'm going to give you the whole rest of the lesson for practice. Okay, so here we go. This time we've got a boat we have a boat modeled as a particle of mass 60 kilograms. It's a light boat. Mass 60 kilograms. Being acted upon by 3 forces. Boom, boom, boom. Now, they're given in column vectors, my buddies, but don't let that fool you. Don't let that fool you at all, my folks. You know the column vectors. It's just this top one is the I and the bottom one's the J. If anything, we prefer column vectors. They've tried to complicate it, but it's actually made it a bit easier for us. So, yeah, nice one question. Cool. Step 1, what do we do? Yeah, that's it. Draw the picture. So here we go. There's our boat. Our boat weighs 60 kilograms. Lovely free body diagram. Okay, first force is 80, 50, which means it goes 50 to the, or sorry, it goes 80 to the right, because that's like the I, right? It goes 80I, and then it goes 50J. Cool, 50J. So there's your F1 drawn out as a vector. Cool. Now, force 2 is the one they're trying to confuse us with P and Q. So let's do it. It's got 10P. Oh, it doesn't actually say if P or Q is negative. So actually, oh, I hope that they are. Oh, I so hope that they are. That would be a really good thing. P and Q could be negative, so I could end up completely mucking up the picture here. But as you'll see, it makes no odds, really. As long as we're consistent, we'll get it right. So here you go. You ready? 10P to the right. So here we go. Ready? 10P. Okay. 10P in the I direction, and then you're followed by, oh, I've not left enough room. Okay, here we go. Let's try again. Oh no, let's try again, my buddies. Let's try again. Okay, so here we go. I'm gonna draw it. How can I draw it? I could draw it to this side if I wanted. I'm not gonna. I'm gonna fit it in anyway. So you ready? Here we go. I'm gonna fit it in. Okay, 10P. So there you go. 10P followed by, and that's in the I direction, followed by, and we've got here 20Q, which I'm not drawing to scale. 20Q in the J direction. You can even bin off your I's and J's, you know, like you don't even have to keep them in your pictures. It's weird that you have to learn vectors. I don't approve, I disapprove. Anyway, that's okay though. This is F2. They're not terribly useful in this context. Cool. And the third one, minus 75 and 100. Well, that one's no problem to draw. I'm going to pop it there. 75 that way then. Minus 75I. And then we've got 100J. 100 up. 100J. Cool. And there's your force 3 then. Now, it does say it's accelerating. It says it's accelerating at a rate of 0.8 horizontally and minus 1.5 vertically. So it's bizarre this to actually put that on the picture. So I think I'm actually not gonna, I'm just gonna write this. I'm gonna write A is 0.8 and minus 1.5, there you go, meters per second squared. Cool, instead of actually drawing it as an arrow, because I think it'll just be awkward. Cool. Right then, buddies, what are you gonna do? Well, we're after P and Q, so what are you gonna do? Well, you're just going to do it, to be honest. Let's go. Horizontal. Or pick a direction to be positive. Well, it's accelerating to the right because the 0.8 is positive. So I'm going to have right as positive. So you ready? FNet. What's going right? Well, you have your 80. From there, you've got your 10P. But you got to take away your 75. Cool, cool, cool. So FNet, though, is MA. So we're going to have 60. Because that's the M. A is 0.8. And on this side, see, I get it, MA. This side, 80 take 75 is just 5 plus 10P. Well, we're ready to solve. You don't have to show any mechanical steps, really. This laying out would have got you all the marks. One for knowing it was an FNet equation, one for correct substitutions, inline substitutions, and one for the answer. This would only be worth 3. So 60 times 0.8 is 48. Take 5 is 43. Divided by 10 is 4.3. Okay. So P then is just 4.3. Now it's not newtons or anything, it's actually unitless. It just happens to be there. It's just one of those things. It's in with the newtons, so it's unitless. It's just 4.3. You don't have to worry about it. It's just 10 lots of that is how quick it's going to the right. Or the force that's going to the right. Cool beans. Vertical now. Vert. Now pick whatever direction you want to be positive. Now, I'm going to pick left just to show you. I picked left because the acceleration is to the left, since this is negative. And I just wanted to kind of break the convention a bit to see what happens if you pick a different way. So you ready? FNet is going to equal, and remember I've got left positive. So, what am I doing? Oh, good heavens, it's not, I said vertical and I said left. That's what my mistake is there. Vertical, pick a direction to be positive. I'm going to pick down to be positive, okay? I'm going to pick down to be positive because this is, it's downward, this acceleration. So you ready? FNet is equal to, and what have we got that's pointed downward? Oh, literally none of them. How exciting. Okay, so it's going to be minus 100 from this one, minus 50 for that one, and then you're going to get minus 20q off the last one. Get that? Because they were all pointed up. It was dumb of me to pick down, probably, as my direction convention, but at least I'm going to get my one advantage, and here comes my one advantage. It's MA, right? So it's 60, but my acceleration is positive 1.5. Yeah, I made that way harder, but you can see that it is quite a lot better if you made it up positive, because you could have just nicked the negative and put it in there. These guys all would have been positive rather than negative on this side. But, oh well, you'll see that I get the same answer as you. So you ready? Minus 150 minus 20q. Cool? Rightio. 6 times 1.5, I think is 90. So we're going to be left with 90 equals minus 150 minus 20q. And I'm going to put this over here. I'm going to get 20q. Yeah, my way makes it hard. Mine is equal to minus 240, is that right? Yeah, because that'd be positive. This would go negative. Minus 204 is going to be negative 12, isn't it? Q is equal to, it is negative 12. 240 divided by 2. Yeah, 240. 24 divided by 2 is 12. Yeah, so 12. Okay, so it's just going to be negative 12. So actually, we got our Q out as a negative. That's no problem at all. Yeah, it's actually good. This is the thing I wanted to happen, to be honest. So these are the two right answers, buddies. And here you go. It's cool. All it means that is that this thing is drawn wrong on our picture. But it doesn't make any difference. We've still got the right answer. Knowing what we know now, knowing now that we know that Q is negative 12, this force actually would have been, because it's negative, it would actually be pointing downward. So the force would be more like that. Okay, that's what the force would actually look like at the end, simply because the Q is going to make the upward part turn into negative because it's negative. Cool beans? It's not super complicated, though they don't want it to be complicated. That final answer there is just pretty much as hard as you need to go. Cool beans. So here we go then, folks. I want you just to try these. Shaboosh. Page 167, question 1 to 10. Just do a mix, okay? That's to do with this new topic. So just do a mix of this new topic. When you finish that, it's the same questions as last time, 3 to 11 from last lesson. Now, they're really important. Well, these are all really important, but 3 to 11 is more like a real physics questions, real mechanics questions. And so it would be good if you kind of get the idea of these and you're content with your mix to have a little try of those, is what I'd suggest. Cool beans, buddies. I shall try to get you guys a revision lesson soon, just to make sure you're all on board with it, and I'll find some proper nasty questions for you to try when I give you that, and that should be good. So that's it from me, my buddies. See you next time. Bye, buddies!